We have finished the discussion on sorting arrays. Now is the time to discuss searching an array for an item in this array. The algorithm that we are going to discuss is called the sequential search algorithm. So what is this algorithm? A search algorithm is a method of locating a specific item in a larger collection of data. We have implemented this searching algorithm in a previous exercises, but we were not aware that it was a searching algorithm. If you remember, we have defined a wrapped class for an array. The array inside was called list. And if we wanted to add an element into the list, the class has to make sure that it was not on the list. To do that, the class used a method called isOnList. So the method searches the array list to see whether it contains the value represented by the parameter item or not. And this was an example of a sequential search of an array. The sequential search algorithm is very simple and straightforward. It looks at the array elements from first to last to see whether the item is equal to any of the array elements or not. The search ends when either the desired item is found in the array or the end of the array is reached without finding the item. The sequential search algorithm, in fact, uses a loop, and its steps can be summarized as follows. First, it compares the key element, which is the element that we are looking for in the array, which is called key. It compares the key elements sequentially. When we say sequentially, it means in sequence, one after the other, from the beginning of the array until the end of the array. Then the method continues to do so until the key matches an element in the list, or the list is exhausted without a match being found. So either the element we are looking for, which is key, is found and we have a match, or the element is not found and we don't have a match. If a match is made, the linear search does not retain the value we are looking for, which is the key. It retains the index, which is the place of this element in the array. So it retains the index of the element in the array that matches the key. Now, what if there is no match? What if the key element is not found? If no match is found, then the search algorithm retains -1 as an indication that the key element is not found in the list. To see how these steps are followed in action, consider the following example. In this example, the element we are looking for is a 3, which is called key, and this is the list, which is an array of integers. The linear search starts from the first element, it goes to the next element until the end. In every iteration, it compares the current indexed variable of the list with key. So the first element is 6 is not equal to key, so it will go to the next one, which is 4, and 4 is not equal to the key. It goes to the next element 1, and 1 is not equal to 3. It goes to 9, and 9 is not equal to 3. It goes to 7, and 7 is not equal to 3. Now we have a match, so 3 is found in the list. So what is the return value from this method? The return value is not a 3. The return value is the place where did we find a 3. And in fact, it is its index. And it returns 5 as the index of the key where exactly it was found in the list. Now suppose now the key is equal to, let's say, 17. And 17 is not on the list. So it will start sequentially looking for 17. It's not equal to 6, not 4, 1, 9. So the loop will exhaust all the array elements. And it will never find 17 in the list. So therefore, the method will return -1. So -1 is an indication that it is not found on the list. Here is the implementation of the linear search as a method. The method has two input parameters, the array and the key, which is the element we are looking for inside this array. It returns an integer as an index. If there is a match, then this index will be the location of this key. If there is no match, then it will return -1. We have a local variable as an integer. We set it to -1 in the beginning, assuming that there is no match. Then the for loop will visit every element in the array sequentially and match it with key. If a match is found, then the location of this key, which is the index, will be returned as a return value for the method. If the for loop exited the loop without a return, that means it has exhausted all the array elements, and that the value of index has never been changed inside the loop. And therefore, the return value will return -1, indicating that there was no match found on the list. To show you how to use this method in a program, suppose we have an array of integers for student IDs of 100 students. We ask the user what is your ID, and we wanted to find out if the student ID is on the list or not. So we call the method linear search. We supply the array as input parameter as well as the ID, which is the key. Then the method will search for the ID inside the array, store the result of the index into ID index. If the return value from the linear search is -1, that means that the ID was not found on the list, and a message will be displayed on the screen that your ID is not found. Otherwise, a message will be displayed that you are registered. That means your ID is found, and the location of the student ID is saved into ID index. So whenever we want to print the ID of this student inside the array, we use this index. So this is how we use the method linear search if we want to find an element in the array. It works the same way as index of method inside strings. Remember, for string that we have a method called index of. It finds a character or a word inside the string. If the character or word is found, it retains its location, its index. This is why it is called index of. Otherwise, it retains -1, indicating that the character or word was not found inside the string. But this is not the only algorithm that is used for searching. There are other searching algorithms, for example, binary search. But to use binary search, as a condition is that the array should be sorted. Otherwise, we cannot use it for searching. We will discuss binary search later in this course.